let's have our letter D. So we will derive the equation of the parabola opening downward. Okay, so from here, let's have this parabola. Okay, so let this be my axis, or axis of my parabola, or at my y and my x, and of course let this be my vertex at 0 0. So opening downward, right? So therefore we will consider this opening downward. Okay, wow, okay. Why cannot I perfect this parabola, right? So I've been doing this for a couple of hours now. Okay, okay, let's call that one a perfect parabola, even though it's not yet perfect. Okay, so let this be our f. Wherein we have, of course, right, we have our a here. So since it is x-axis, so I will consider this as 0, negative a, and then directrix, which has, since our vertex is our midpoint, so I am saying a couple of times, so this is our a, so this is equal, this has equal length. So therefore our directrix, or the point that is connecting the directrix, that is within the directrix and within the axis, is we have 0, positive a. So therefore we have y is equal to a. Therefore the equation of the directrix will be y minus a is equal to 0. So directrix, okay, this will be our directrix. Like our previous example, we will have another lines within our parabola. Let's call this as my point xy. So therefore, since this is my point xy, this point must be perpendicular to my, okay, I'll just put it here so that it will not become our latus rectum though. So you have point xy. Okay, let's call this as point xy, and there would be a line that is perpendicular to our directrix. Okay, so what point will be, what will this point will be? Let's call this as our, okay, x, right? So x from the point x here, xa. Okay, xa. So from that I will have my point xa and my point 0, negative a. Okay, so from here the next thing to do is, of course, this must be equal to this. So fp must have a similar link with my PD, wherein from point to directrix and my focus to my point. So PD must be equal to my FP. But what is my PD? So our PD will be simply be equal to, PD is equal to the distance formula. So x minus x square plus a minus y square, and by simplifying this I will have a minus y square for my PD, and for my FD, so we'll have FD, so we have FP, I should say. So FP, so we have square root of x minus 0 square, and we have plus y minus negative a square. So from here, by further manipulation the formula, I will have square root of x square plus y plus a square, right? Okay, so from here I will have my PD is equal to my FP, so therefore we will have square root of a minus y square is equal to square root of x square plus y plus a square. So if you square both sides, we'll have a minus y square, which is equal to x square plus y plus a square. So by further manipulation of this equation, I will have a square plus minus, let's see, minus a square minus 2ay plus y square, which is equal to x square plus y square plus 2ay plus a square. So you would notice that a square minus a square is 0, okay, and y square minus y square is 0, right? Y square minus y square is 0. So I would transpose my x square will be equal to negative 2ay minus 2ay. So our x square will be equal to negative 4ay. This is true for, or this will be the equation for our parabola that is opening downward. Now these are the standard formulas of our parabola at vertex 0, 0. If there will be an hk, just like our circle, we will just subtract our h to x, so x minus h, and my y minus k. Okay,